You flick a switch and the light just comes on. It's so simple, right? But behind that one simple action is, and I'm not exaggerating here, one of the most complex machines ever built, the electric grid. And keeping that thing running, well, that's a whole other story, powered by an invisible world of really sophisticated software. So let's pull back the curtain and see what's really going on.
Okay, so think of the power grid like a tightrope walker. Seriously, on one side you have all the supply, the power plants, solar farms, wind turbines, and on the other side you've got all the demand. That's every single phone, every factory, every light bulb being turned on. The utility's entire job is to keep that tightrope walker perfectly balanced every single second of the day. Because if it tips too far in either direction, blackout.
And that, right there, is the multi-billion-dollar question. How on earth do you manage this huge, sprawling system where solar panels just go offline when a cloud rolls in, and demand suddenly spikes when everyone gets home from work at the same time? You need a brain, a really, really smart one. And get this, that future is already being built. This quote here, this is from an Oracle Energy Conference agenda. This isn't science fiction. They are literally talking about using AI, virtual reality, even talking to an asset. It just gives you a peek into how ridiculously high-tech the world of electricity has become.
So, what's the end game here? What's the point of all this futuristic tech? Well, it all comes down to solving a few massive core challenges that every single utility on the planet is wrestling with. It really just boils down to these three big things. Reliability. You want the lights to stay on like 99.999% of the time, no questions asked. Sustainability, that means figuring out how to bring in all the new solar and wind power without making the grid crash. And of course, efficiency, squeezing the most power out of the system with the absolute least amount of waste. And this is where it gets really cool. This is how they're planning to do it. We're talking about drones that fly themselves out to inspect power lines, creating a complete digital replica, a digital twin of the entire grid so they can run simulations. AI is even handling things like customer service calls and managing your smart thermostat right from the control room. This is the smart grid everyone's been talking about, coming to life. But look, to make any of that magic happen, you need a central command center. You need one single, powerful piece of software that can see everything and control everything. This is the grid's brain, and it's called the Network Management System.
The absolute best way to think about this software, this Network Management System, or NMS, is to picture it as the grid's central nervous system. It feels what's happening, it reacts, and it makes all the critical decisions to keep the entire system healthy and running smoothly.
So the first part of this nervous system is something called SCADA. Just think of it as the raw sensory input. It's the eyes and ears out on the grid, collecting real-time data from every transformer, every switch, every sensor out there. It's the part that tells the brain exactly what's happening right this second. Okay, so what happens when those eyes and ears spot a problem? Or, more likely, what happens when your power just suddenly goes out? That's when the next system kicks in, the OMS, or Outage Management System. This thing is the emergency first responder. It logs your outage call, it uses data to predict where the fault is, and it gets your repair crew rolling.
But you don't want to just react to emergencies all day, right? You want to prevent them from happening in the first place. That's the DMS's job, the Distribution Management System. This is the optimizer. It's constantly analyzing power flow, rerouting electricity to stop overloads before they happen, and just generally keeping the system perfectly balanced during normal, everyday operations.
And that brings us to the newest kid on the block, the system that's really built for the future, DERMs. This system is the great orchestrator. It's designed to handle all the new, decentralized stuff. Your rooftop solar panels, your neighbor's EV charger, that big battery farm down the street. DERMs is what allows the grid to actually see and use all of these newfangled energy sources.
So we've got this incredibly powerful, absolutely mission-critical piece of enterprise software. It's the brain, the command center, the whole shebang. But what is it actually made of? What's under the hood? Well, the answer is probably not what you think.
Let's be honest. When you think of a huge enterprise software company like Oracle, you probably think of proprietary, locked-down, secret sauce technology, right? So what do you figure is at the very core of their multi-million-dollar network management system? Believe it or not, if you actually dig into the official licensing manuals for Oracle's NMS, you find something amazing. This critical piece of national infrastructure is built on a massive foundation of hundreds and hundreds of open-source software components, all created by a global community of developers.
And just look at the sheer variety here. It's kind of wild. We're seeing everything from legendary stuff like Apache's logging libraries and the Python language itself, all the way to Google's core libraries for Java and even the Chromium framework. That's the engine that powers the Chrome web browser. It's a huge testament to just how powerful the open source world has become.
Now, the crucial thing to understand is that each of these little pieces of code comes with a license. Think of it like the legal rules of the road. Some, like MIT, are super permissive. They basically say, hey, do whatever you want with this. But others, like the GPL, are much stricter, and they make sure that any software built with them has to also be open for everyone to see. It creates this really complex but powerful legal web.
Of course, software this important doesn't live on an island. It's just one very, very important layer in a much bigger stack of technology.
You can see here it's kind of like a big layer cake. The NMS application itself sits way up at the top, but underneath, it needs an operating system to run on, like Windows. It needs a massive enterprise database, an application server, and this is a big one, it has to plug into Geographic Information Systems, or GIS, so it can actually map out the entire grid. Every single link in that chain has to be rock solid.
And all of this complexity creates this giant constant challenge. It's summed up perfectly in one of the cybersecurity talks at that Oracle conference. You have this constant tug of war. The goal is to give business users the data they need to do their jobs, but the challenge is keeping that supercritical operational data safe from attack. It's a battle that never, ever ends.
All right, so after diving deep into all that technical detail, let's zoom all the way back out. Why does any of this actually matter to you when you just want to flip on a light?
Because that one flick of a switch depends entirely on this. It relies on a huge proprietary system from a company like Oracle, which, in turn, relies on this massive, global, decentralized community of open-source developers. It's this hidden partnership that literally keeps our modern world humming along.
So, if you take one thing away from this, it should be this: that invisible software infrastructure we've been talking about is the whole ballgame. It is the key that unlocks the door for utilities to tackle those huge challenges of reliability, sustainability, and efficiency. It's what makes modern life possible.
But all of this leaves us with one final, really important question to think about. As our homes and our cars become active participants in this smarter grid, generating enormous amounts of data that's managed by this complex web of software, who truly owns the code, and more importantly, the data that powers your life?